Hi everyone, this is one of the first videos on lesson 7.4 and 7.5 on exponential growth and decay functions. Today we're just going to take a few moments to explore the nature of exponential functions and get you prepped for the first lesson that you'll watch in a video tonight for homework. So also, if you are an in-person learner today, then you don't have to watch this video because we're going to do this activity today in class. And also, before you start, then you will need to get your graphing calculator out because we're going to be typing these questions into our graphing calculator. So, and learning some really important graphing calculator tricks. So you want to make sure that you have your calculator out with you and not just the Desmos calculator. So the first task that we're going to do is create a table of values for the function y equals 2 to the x. So an exponential function, let me go back to this slide. Exponential means that the x is in the exponent. So x is in the exponent, which is totally new to us. So when we have an exponential function, we'll have, there's a form to it that we'll discuss later, but it's basically a times b to the x. We're not going to have any a's for now. We will in a moment, but we'll just have the b to the x, where b is the base, and it's going to just be a number, a fraction, or a whole number. And then to the x, where x is your exponent, that is your variable. So y equals a times b to the x. So we're going to look at a couple examples and see what exponential functions, how they behave on a table of values, and how they look like on a graph, or what they look like on a graph. So what we're actually going to do is we're going to take our calculator and we're going to type in 2 to the x in our y equals. So go to your calculator, go to your y equals, and then delete anything or clear anything that's already there, and type in 2 to the x. Now to get the exponent, you type the little caret symbol here above the division sign, and then type in the x, which is right next to the green alpha button. Right, once you do that, you're going to press zoom, the zoom button up here in the middle, top middle of your calculator, and 6, because that's the standard window. So zoom 6. Ignore any of the dots that are there. That's fine. That's just from your plot when you were doing statistics in the last unit. So anyways, so this is different than what we're used to with lines. This is clearly not a line because it's curved. So exponential functions, they don't work like a line. And also, do you see how this part over here to the left, it looks like it's going along the x-axis? Well, actually, if you zoom in a little bit, and I'll teach you how to use the zoom feature later, but if you zoom in, I'm just gonna, well, here we go. I'll teach you how to do this later. If you zoom in, well, it doesn't quite show you, but if you zoomed even more, it doesn't quite get to the y-axis. It gets very, very close, but it never reaches the y-axis. And that's because basically if you do 2 to the anything power, you're never going to be able to get 0. You'll either get a fraction or a whole number. So anyways, how do we fill in the table? We're going to explore a different feature here. We're going to go to, where is it? Table. You see the table here? So go to second graph. And now you have your table of values. Now yours probably starts at 0. So in order to see -2, you're just going to press the up arrow. So also if you keep pressing the up arrow, see how the numbers in the y get really, really small, but they never quite get to 0. And e to the -4 just means a really, really small number, scientific notation. So that's what I was just kind of talking about. So anyways, so scroll down so you can see the numbers that you need. So you do -2 is 0.25, -1 is 0.5, and I'm gonna split my screen here. So we'll do 0.25, or you could say 1/4, and then 0.5 would be 1/2. 0 is 1, because remember, if you do 2 to the 0 power, you get 1. And then 2 to the first power is 2. 2 to the second power is 4. And let's also do 3. 2 to the third power is going to be 8. All right, so then let's plot these points on our graph. So at -2, we're at 0.25. At -1, we're at 0.5. At 0, we're at 1. And then we have 1, 2. And then we have 2, 4. And then we have 3, 8, which normally we wouldn't plot it since it's not on the graph, but we will here. And then you very carefully draw it on your graph. So I hope you're drawing this with me, okay? And then it's just going to keep going up steeper and steeper. So notice that if you're squaring something and if you keep raising it to the next power, if you keep going, the numbers in the x get exponentially large. That's how we say that. So if you keep going, it gets even bigger and bigger. So basically, we're just doubling each number for each x that we're adding. So it gets exponentially big. That's what we call exponential growth. I guess we'll throw that term in here. Exponential growth. Okay, and then also what you want to note that is you're never going to cross the x-axis or the y-axis here. So don't go like that. Okay, that's bad. Just leave it here. Do the arrow because remember, it never crosses the y-axis. It just gets really close to it. All right, let's do the next question. So the next question is going to be similar, except it has 1/2. So let's go back and let's go to our y equals. And then let's type in, let's go ahead and clear this and type in parentheses 1/2. Also, if we type our equation with the fraction button in, then it's going to give us our table of values in fractions. If you do 0.5, then it'll give you the table values in decimals. And then to the x power. Okay, so press zoom 6. And then you see how it's just the opposite? Because if 2 and 1/2 are reciprocals of each other, then with the graph, it's just going to be the opposite. So it's going to be going, this is called exponential decay, because as you're moving your graph to the right, the graph gets closer and closer to 0. But remember, it never crosses 0, and it never touches 0. It just gets really close to 0. Because if you keep dividing a number by half, then it's just going to get really, really small, but it's never going to get to 0. So let's go back to our table. So go second table, and then we want to go up to -2. So -2 is 4, -1 is 2, 0 is 1. So basically it's just the opposite of what we put above. So this would be 4, 2, 1, 1/2, and 1/4. And just as a little explanation, if you do 1/2 to the -2nd power, remember, to get the exponent to be positive, you flip the fraction, so it'd be 2 to the 2nd power, which is 4. And then remember, if you do 1/2 to the 0, anything to the 0 power is just 1. If you do 1/2 to the first power, you just get 1/2, etc. All right, so then let's put this on our table. So -2 is 4, -1 is 2, and then 1, 1/2, 1/4. And then very carefully connect your dots. No lines here, just curves. I know it's a little bit tricky. Notice I'm not going to cross my x-axis. I'm sorry, I was calling this the y-axis earlier. I'm not going to cross my x-axis. I'm just going to get close to it and then draw my arrow because it never crosses. Okay. Now here, describe the difference between 2 to the x and 1/2 to the x. What similarities do you notice? All right, so we're going to say that 2 to the x is increasing by a factor, because factor means that you're multiplying, of 2. Whereas 1/2 to the x is decreasing, which we also call decay, by a factor of 1/2. And then what do they both have in common? Well, they both have in common the y-intercept. They both have a y-intercept at 0, 1. So I'm going to attempt to move this up. Okay, so both have a y-intercept of 0, 1. And you could also say that they're reflected in the y-axis. Reflected in the y-axis. All right, let's do a couple other examples. So let's look at different kinds of exponential growth functions, 2 to the x, 3 to the x, and 4 to the x. So we're going to put, and then we're going to compare them, see what's similar, and look at their y-intercepts. So go back to your calculator, go to your y equals, clear that. You're going to type in 2 to the x, and then 3 to the x, and then 4 to the x. And then it says to use the window -5 to 5, -5 to 5. So actually in my window, I'm going to do -5 to 5, and then -5 to 5. And then I'm going to press graph, because if I press zoom 6, it'll bring me back to -10 to 10. So press graph. So the blue is 2 to the x, the red is 3 to the x, and the black is 4 to the x. So which one is steeper? Which one is steeper? So which one, if you were walking up the hill, would you have a harder time walking up? I would say the black one. So 4 to the x is steepest. We're going to say that. 4 to the x. Actually, that's kind of question 3. So we'll hold off on that. What is similar about the 3 graphs? Well, they all have the same y-intercept. So y-intercept is the same. And because, well, when you're finding the y-intercept, you're plugging in x equals 0. And anything to the 0 power is 1. Because 2 to the 0 is 1, 3 to the 0 is 1, and 4 to the 0 is 1. So that's why they all have the same y-intercept. And then, I think I just need to, there we go. So different. So 4 to the x is steepest, rises the fastest, and then 2 to the x is least steep. And then we're going to try putting a negative sign in front of each function. What do you think would happen if we put a negative sign in front? Well, it's just going to make every value negative, so it's going to make it go down. So let's try it. So do second insert, so second insert negative, or you can just retype it in everything. Second insert negative sign, second insert negative sign, press graph. And then, yep, so the black one is still the steepest. It's just going in the opposite direction. It's going down. Now, this is still exponential growth because it's growing. It's just in the negative direction. Also, if you go to the table, you can see how the black one, like look at 8. If your function is at 8, then 2 to the x is -256, 3 to the x is -6,000, and 4 to the x is -65,000. So look how much bigger 4 to the x gets just by multiplying everything by 4 each time. So see how rapidly the numbers increase in the negative direction. That's what's happening here. increases in the negative direction. That's what happened. All right, and we're going to do one more thing and do the same thing, but with the 1/2. So we'll go to our y equals here. We'll clear everything. We're going to type in 1/2, 1/3, and 1/4. Oops. 1/2 to the x, 1/3 to the x, and 1/4 to the x. I'm going to click graph. Now, basically the same thing is going to happen. So the black line is still going to be the steepest. And if you look in the table, the numbers, for the black one, 1/4 to the x, gets smaller quicker. Because 1/4,000 is definitely a lot smaller than 1/64. So same thing, same as number 2 above. And then the difference is that 1/4 to the x gets smaller faster, or instead of smaller, you can say closer to 0 faster or fastest. And then if you put a negative sign in front, it would be the same thing, but going in the negative direction. Also, this is exponential decay, so it decays. So when it decays, because it goes to 0, but from the negative direction. So let me show you what that looks like real quick. And I have one more kind of interesting question for you. So notice I said it decays because it still gets closer to 0, but from the negative direction. So it starts over here and then gets closer to 0. So my question is, do these graphs have a slope? Is there a slope with these graphs? Now, remember, the definition of a slope is a number that the function is constantly increasing or decreasing by. However, with exponential functions, you're not decreasing or increasing by the same amount each time. You're increasing by the same factor. So this would be no, not increasing or decreasing by the same amount, but the same factor. All right, so this introductory lesson should prepare you for the first day of actual notes and actual practice with exponential functions on your own. Right, so I hope you enjoyed this video and you guys have a great day.